We are continuing with day 15. We just solved day 14. And let's see. As I said previously, when I was trying Advent of Code 2022, I was able by myself to solve up to day 13 in Pudding. And 2020, I try some examples. I get up to day 10. Both times I use Go, which is not my primary language, and here we're using Go because of it's a really simple and clear language, and we don't want to waste too much time of using something too complicated that requires very specific knowledge. Fast recap: we're having every part in its own folder. We are copying previous day usually, and the folder structure, let me rename that to day 15 part 1. We have our input, which is specific for my account. Everything is submitted in the request. We have a main file that simply contains the code. We have a file with all of our prompts, including the answers. For example, what we give for a context, as here, for example, and we have also test file, which is part of the description of the problem. Let's look at the problem. Advent of Code 2021, it's in the ocean. We're in submarine and we're navigating in caves, and we were escaping for some sea creature. And now you've almost reached the exit of the cave, but the walls are getting closer together. Your submarine can barely still fit. Okay, it's saying that we don't have enough space. The main problem is that the walls of the caves are covered in chitons, and it would be best not to dump any of them. Let's see what is this chiton. Chiton is marine, more or less. That's a creature. Okay. Sea cradlers. Okay, interesting. I haven't heard of them. We don't want to hurt them. The cavern is large but has very low ceiling, restricting your motion in 2 dimensions. Okay, we can move only in 2 dimensions. The shape of the cave resembles a square. A quick scan of chiton density produces a map risk level that it's telling us where we can go. Throughout the cave, your puzzle input. We are getting this example input. That's the risk level on our 2-dimensional grid. We put stuff like that in our Advent of Code, here in our test file. And we have saved, we have that saved, here it's saved, and we have this one saved. In our input file, what's our goal? You start in the top level position. We are somewhere here. Your destination is the bottom right. We need to get up here, and you cannot move diagonally. I can go left or down. Can I go up? The number of each position is its risk level. To determine the total risk in an entire path, map the risk level to each position you enter. That is, don't count the risk level of your starting position unless you enter it. Leaving it adds no risk to your total. Don't count the risk level of your starting position unless you enter it. Leaving it adds no risk to your total. Okay, in our case we start from here, we're going through the whole thing and we need to get 40. And our goal is to find the path with the lowest total risk, or so to say, using Dijkstra or some other algorithm to find the shortest path. If we have our risk as okay, let me go to our prompts. We simply prompt this kind of stuff. Hop. And before to forget, let me get as you can see, as expected, the input is much bigger than our test input, but all that is okay. Let's here we're saying again for new people to our prompting technique, we're giving to the algorithm context that you're a prominent competitive programmer, you've been invited to participate in programming competition, you're given a task to solve. The instructions are: write a Golang program that solves the task and read the input from a text file, and after that we simply copy and paste the input. And without further delay, let's go to ChatGPT and jump on our GPT-4 quest. Solve this problem. You can use Dijkstra algorithm to find the shortest path from the top level to the bottom right corner of the grid. Here is a Golang program that reads the input from the name and solve the task. We have the position because we need to have a row and column. Mean risk is find the risk. We have it split it as a read input, opening the file. We have a grid that is integer, perfect. We don't need anything more than that. And I think in our case, let me double check. Yeah, the input is from 1 to 9. You can use yeah, and it's perfectly fine. We have find mean risk path. We are checking if we have visited stuff. We are initializing it to a huge number. We can simply use 10. No need for that, but yeah, it's fine to use these ginormous numbers. We have a current position that it's position out of the board. That seems reasonable. We're checking and updating that the given position is visit. After that we have the direction, next row, next column, etc. New direction. Okay, let's that's our program. Let's have it here. Is it we're getting the risk that we expect. Let me simply pause that, make sure that we are not forgetting the answer. The answer is perfect. Here we have our Go program. Go. We have copy of the Go program. The extra we have this bit here, and we need to close the program, and let me try it with the input. We have 398, and let's see if that is solving the part 1 of day 15. Okay, thank you for your time, and see you in the next video.